Hello, and today I'll be teaching you about Chapter 8.5, Intersections of Lines and Planes. So, with intersection of lines and planes, there can be three different types of solutions. The first type of solution is that there are no solutions, meaning that the line and the plane are parallel from each other and do not intersect. The second type of solution is that there are an infinite number of solutions because the line lies on the plane and every point of the line is intersecting with the plane. And the last and third solution is that there's only one solution, meaning that the line intersects with the plane at one certain point of the line, and at that point, the line passes through the plane. So there's only one solution. So to determine if the line and the plane are intersecting, or if they are parallel and have no solution, or if the line lies on the plane and there are infinite number of solutions, we need to have the plane scalar equation and the parametric equations of a line. With these equations, we sub in x of the parametric equations into the plane scalar equation. So it will end up looking something like this. A xo plus ts plus b yo plus ts plus c zo plus ts equals to d. If t ends up being solved for and it has a value, that means there is one solution. That means that the line and the plane are intersecting at one certain point. If t ends up being canceled out and it has a constant, which would just turn into like something like 9 equals to 9, that means that there are an infinite number of solutions and that the line lies on the plane. And lastly, if there is an equation that doesn't make sense, so it'll end up being 15 equals to 0 for an example. Since this cannot happen, that means that there are no solutions and that the line and plane are parallel to each other. Okay. With this certain type of solution, where the plane and the line are parallel from each other, we can always also find the distance between the two. We can find the distance between the plane and the line. We can do this using the equation distance equals and then the normal vector dot product PQ over the normal vector of the plane. So we can easily find n, the normal vector, is equal to a, b, c. The normal vector of the plane is equal to a, b, c, where you can get it from the scalar equation of the plane. A, b, c. Those values. P is equal to any point on the plane, on the line, any point on the line. And Q is equal to any point on the plane. Right? So we can solve for Q with the scalar equation of the plane. You are basically creating these values. So Q will just be any x, y, z value, x, y, z value that will satisfy the plane scalar equation. once you have those values, you can find the P, which is any x, y, z value, where you sub in T for a number. Because XO and S1 and YO, S2, and ZO, S3 will be given for the parametric equations. And all you need to do is sub in the T value and create values create the point on the line. So this could be, if T is equal to 0, you would have XO, YO, ZO. And that will be the equation. With that, you can easily find PQ, right? And you have the normal vector. And you sub in the values back in, use dot product between the normal vector and PQ, and then divide it by the normal vector. And the answer will be in units. So 1 unit away from the line and plane, or 1 unit away from each other, or 2, or 3, or whatever value is found out. And that's how you solve for the distance between a line and a plane when they have no solutions.
And now we'll be looking at some examples. This example asks us to state the solution for this system. Now, in order to do this, we first need to find the parametric equations. And we are able to do this by looking at this equation right here. Okay, so we start off by finding the x value, which is 6 plus t. And then we find our y value, which is 11 plus 5t. And then our z value, which is 1 plus 2t. And now we need to sub in our parametric equations into our scalar equation, which is given to us. So, x plus 3y plus 2z minus 1 is equal to 0. We sub in our variables, which we know. So x is 6 plus t plus 3, 11 plus 5t plus 2 times 1 plus 2t minus 1 and equals 0. And now we need to isolate for t. So it becomes 6 plus t plus 3 times 11, which is 33, plus 3 times 5, which is 15t, plus 2 plus 2 times 2, which is 4t, minus 1 is equal to 0. And then this, we collect like terms now, so it becomes 20t plus 40, which is equal to 0. So 20t is equal to negative 40, and t is equal to negative 2. And now since we know the value of t, we're able to sub that back into our parametric equations. So x is equal to 6 plus t, and we know that t is equal to negative 2, so it's 6 minus 2, which is 4, and y is equal to 11 plus 5t, so that becomes 11 5 minus 2, so that's 11 minus 10, which is 1, and then z is equal to 1 plus 2t, so that becomes negative 3. Oh my God. Therefore, the solution is 4, 1, and negative 3.
For the question, verify that the line and plane are parallel, then determine if they are distinct or coincident. We have the plane scalar equation 2x plus y minus z equals 5, and the lines equation here, RO plus TS. So first, we can turn the lines equation into its parametric form, which is x, y, and z is equal to, so we'll take the x values, 2 plus 3t, the y values, 1 plus negative 2t, and the z values, 5 plus 4t. With this parametric equation of line, we could sub in x, y, and z into 2x plus y minus z equals 5. So we'll have 2, so sub in x for x of the line, 2 plus 3t, plus the y, which is 1 plus negative 2t, so we can simplify that to 1 minus 2t, and minus 5 plus 4t. 5 plus 4t, that will be in brackets, is equal to 5. So we'll use distribution to solve for t now. 2 times 2 is 4. 2 times 3 is plus 6t, plus 1 minus 2t, minus 5 minus 4t is equal to 5. Collect like terms, so 4 minus, plus 1. This looks more like a 1. There we go. Minus 5. And plus 6t minus 2t minus 4t equals to 5. So here we now have 4 plus 1, 5, minus 5 is equal to 0. So this will cancel out. Plus 6t minus 2t minus 4t. So this is minus 6t plus 6t, which means it will be equal to 0 as well. So we now have 0 equals to 5. Since this equation cannot be true, this means that there are no solutions and that the line and plane are parallel. And plane are parallel. There we go. Because we know that the line is not on the plane and that there are no solutions, we can also say that the line and plane are parallel and distinct, because the line does not lie on the plane.
So now the third example asks us to find the distance between the parallel line and the plane. In order to solve this question, we need to determine the normal vector. So that is n is equal, and that is based on the scalar equation, which is right here. So n is equal to 3, 6, and negative 2, as you can see from this equation right here. Now we need to find a point on a line, and in order to do this, we have to look at the line equation and the parametric equations of the line. So that is x is equal to 0 plus 4t. So it's just 4t, and then y is equal to 2 plus, negative t. So 2 minus t, and z is equal to negative 5 plus 3t. So it's negative 5 plus 3t. So now I'll just let t equal to 1. So the value of x becomes 4. The value of y becomes 1. And the value of z becomes negative 2. So therefore, we'll say the value of p is 4, 1, and negative 2. So now we need to find a point on the plane, and we need to find points that satisfy this scalar equation. So 3x plus 6y minus 2z is equal to 15. So we need to find points that makes it so that left side is equal to right side. And those points are 1, 3, and 3. Because solving all of this gives you a value of 15, and therefore left side is equal to right side. Therefore, the point Q can be 1, 3, 3. And now we need to find vector PQ. So in order to do this, we take our point P, which is 4, 1, and negative 2, and we take our point Q, and now we need to find our vector PQ. So that is 1 minus 4, and then 3 minus 1, and 3 minus 2, so that's 3 plus 2, and that gives us negative 3, 2, and 5. And then we're able to use this formula. Distance is equal to the magnitude of n vector dot pq over the magnitude of n. So that becomes 3, 6, negative 2 dot negative 3, 2, and 5 over the magnitude of the n vector. So that's 3 squared plus 6 squared plus minus 2 squared. And then that gives us negative 9 plus 12 minus 10 over 7, which is 7 over 7, and that's 1. Therefore, the distance between the line and the plane is 1 unit. The fourth example asks us to find the distance between two planes, which are represented by these two equations. A point in the first plane is P, which is 0, 7, and 0. This is a point on the first plane because the left side is equal to the right side. A point on the second plane is Q, 0, negative 8, and 0. Because with these points, the left side of this equation is equal to the right side. And with this, we are able to find vector PQ, which is 0, -15, and 0. In order to determine the normal vector, we look at this equation, and so the normal vector becomes 3, 1, or sorry, -3, 1, and 2. And then we're able to use the distance formula, or sorry, the distance equation, which is n dot pq over the magnitude of n. And so this becomes the normal vector, which is -3, 1, and 2 dot pq, which is 0, -15, and 0 over the magnitude of n, which is -3 squared plus 1 squared plus 2 squared. And by doing all this, you get an answer of 15 over root 42.
For the question, without solving, determine if the line and plane intersect. So we have the line equation, 101 plus t, -2, 1, -4. And the plane's equation, scalar equation, 4x minus 2z equals 11. So to find out if they intersect without solving, we can use dot product to figure out if they are parallel from each other. So we can use m is equal to -2, 1, -4, 2, 1, -4, and n equal to 4, 0, -2, the n, which is the normal vector of the plane, and we got this through the a value, the b value, and the c value. And since there's c is 0 and there's no y, a is 4, b is 0, and c is -2 with a z. So we can solve using if m dot n equals 0, they are parallel. Okay, so we can find this out right now. M dot n equals -2 times 4, -8, plus 1 times 0 is 0, plus -4 times -2, which is 8. So -8 plus 8 is equal to 0. M dot n is equal to 0, therefore the line and plane are parallel. Therefore the line and plane are parallel. But this does not mean that they do not intersect, because the line and plane can be parallel and can either be distinct or coincident. To determine this, we have to use a test value of any point on the line, which is, we can use 1, 0, 1, and sub it in the plane scalar equation to determine if the line lies on the plane. So we can do this using plane equals 4 sub in x1 minus 2, 1 equals 11. 4 times 1 is 4, minus 2 times 1 is 2, equals 11. 2 equals 11. Since this is not true, that means the line does not lie on the plane, and that the answer is that they are distinct. So that means they are away from each other, and it's not, the line is not on the plane, but far apart from it.
And now I'll be showing you how to solve an application question. The question states, Jack and Tony were watching television. The equation x plus y plus z is equal to 8 represents the direction Jack is viewing the television screen. Tony thought it would be funny to mess with him and point a laser on the television screen. This equation represents this. Determine the point at which the laser hits the television screen. Now, in order to solve this, we need to figure out the parametric equations. The way we do this is by looking at this equation right here. So, that becomes x is equal to 3 plus 6t, as you can see from here. And then y is equal to 4 plus 2t. So that's 4 plus 2t. And now the z, which is 8 plus 4t. So 8 plus 4t. And now we take these parametric equations and sub it into our scalar equation, which is this. So it's x plus y plus z is equal to 8. And we sub in the parametric equations for each variable. So that becomes 3 plus 6t plus 4 plus 2t and plus 8 plus 4t, which is equal to 8. And now we just isolate for t. So that becomes like so. 4t equals to 8. And now we find like terms. So it becomes 4t minus 1, which is equal to 8. And so t is equal to 2. And now that we found the value of t, we can sub this into our parametric equations. So that becomes x is equal to 3 plus 6t, so 3 plus 6 times 2, and that becomes 15. And then we have y is equal to 4 plus 2t, and we sub the t value in, which is 2, and we get y is equal to 8, x is equal to 15, and z is equal to 8 plus 4t. Again, sub the value of t, which is 2, and now z becomes 16. And so, therefore, the point at which the laser hits the television screen is 15, 8, and 16.